Hi, I hope you're doing well. My name is Noah Flores, and today I will be covering geosynthetics. So, first, I'm going to start with a little introduction to explain what geosynthetics are, then going to move on to the equipment needed to install said geosynthetics, then going to talk about what types of geosynthetics there are and what kind of costs come with each one, their safety applications in the field, their local applications or pretty much where they're used in Texas, a quick summary, my references, and then some questions at the end. So, first and foremost, what are geosynthetics? They are a planar product manufactured from durable polyethylene or polypropylene polymer material. Little tongue twister, but hey, I got it. What they do is they mitigate the impact water has on the soil below. Spoiler alert, they're usually used on highways and roads, but what they do is they just kind of keep the soil underneath the highway or road from moving around so we don't experience cracks as much. Because if we didn't have these, roads would be breaking more often, they need to be replaced and all that kind of stuff. So this just really helps mitigate like erosion of soil underneath the highway, all that kind of good stuff. Same deal with water. It keeps the water out of there so that it doesn't uh, compact the soil underneath, all that good stuff. So, the equipment that you need to install these geosynthetics is not very much, but what I have here is the process or just all the equipment that is needed to build a highway from start to finish. So, first you're going to need to excavate the roadway to the desired elevation and then fully compact that subgrade. Once that's done, you're going to lay down your geosynthetic and or geotextile fabric, and then you're going to need to bring in the only piece of equipment you'll need for the geosynthetics themselves, and that is a heavy duty sewing machine. You cannot come to the job site with your grandmother's sewing machine, it will break. Then next, you're going to need to lay down some aggregate. And to lay down that aggregate, you're going to need a dump truck because you ain't going to carry that bag by bag. Then once you're done with that, you're going to need to lay down the asphalt and or pavement, then compact it with a compactor, and then paint the lines on it once that's all done. So really, all in all, all you really need for geosynthetics themselves is that heavy duty sewing machine. Now I'm going to talk about what types of geosynthetics there are and the costs that come with each one. So first is geotextiles, which is the most common geosynthetic you'll come across in the field. They usually have this grid slash net-like pattern. They come in different sizes and gauge, but they all pretty much do the same thing. It's they grip into the soil below to mitigate erosion and just make it more grippy so that the road doesn't move around. Uh, they usually range from 30 to 70 cents per square foot, and that's about it for geotextiles. So next up is geogrids, and they're used to stabilize and reinforce soils. Pretty much, this is geogrids are a type of geotextile. Same with the geonets that are a little later here in this slide, but geogrids are used to stabilize and reinforce soils, round foundations, and earth retaining structures, and their cost ranges from $1.50 to $4.50 per square foot. Next, we have geomembranes. Now, these are a little different. These are plastic sheets used within soil as a waterproof barrier. So, what these do is they mitigate the amount of water that goes below um the subgrade. They keep all that water from moving around the soil underneath the road so that it doesn't it doesn't create air gaps, which would lead to cracks. So, these geomembranes are very, very important, and they only cost from 3 cents to 25 cents per square foot. Next up is geocomposites, and they're a combination of one or more geosynthetics used for drainage behind retaining walls and bridge abutments. They usually cost from 4 to 7 cents per square foot. Next is the most expensive, which is geosynthetic clay liners. They're used in hydraulic barriers to water and other liquids, and even gases. So these can be used in chimneys as well, and they cost from $1.50 to $5 per square foot. And now here, like I was talking about earlier, I have geonets. These are used in combination with other geosynthetic products to provide additional reinforcement and support. They cost from 3 to 8 cents per square foot. Now, lastly, I have geofoam. Geofoam is used to support highway loading without overstressing the underlying soils and reduce differential movement. They cost from $2 to $4 per square foot. Now geofoam is different from all the rest, but it still works in pretty much the same way. Now, we safety applications in Texas. Earthworks will be involved when geosynthetics are used in construction and engineering. A large amount of earth may be needed to be moved for the construction of roads, stable slopes and walls, and other situations involving geosynthetic reinforcement of soils and stabilization of aggregates. One of the advantages is the use of geosynthetics is that their use can mitigate how much earth must actually be disturbed. Mechanical stabilization enables steeper slopes and smaller job site footprints. The lightweight of materials such as geocells and geogrids allows large quantities to be delivered efficiently without or with fewer truckloads. They also minimize the amount of soils and fills that might need to be brought into the job site. So this pretty much just means there's less truckloads, fewer liability factors, overall safer work environment. It's not a world of a difference as far as safety is concerned. Sorry, I wiped my screen off. It's not a world of a difference as far as safety is concerned, but it's still a little bit. Now, their applications in Texas, in short, they pretty much use them on highways most of the time, to keep water out, to both keep water out from underneath the road and to make the road grippier so that whenever people drive over them, the highway doesn't get ripped up. But improper usage or installation has contributed to early failure in some cases. The department's geosynthetic usage has increased in recent years with good success. Applications have been in asphalt concrete overlays, aka highways and roads, of existing asphalt concrete and hydraulic cement concrete surfaces, roads, unbound base, soft subgrade, drainage, and encapsulation. Shared terminology exists between these applications. Several of these materials are available for incorporation into pavement structures like highways and roads. So, in conclusion, geosynthetics are imperative for ensuring that pavement grips into the soil slash aggregate and subgrade below, as well as drainage, filtration, separation, and water movement. They ensure that pavement, or I was supposed to say ensure. They ensure that they ensure that the pavement slash asphalt doesn't get ripped up when driven over, and that the soil underneath the road won't get eroded, leading to damage. Here's my really long or relatively long reference page. And lastly, I have some questions here. So, for question one, what is the most expensive geosynthetic? Now, I don't expect y'all to remember the prices, but the geogrids cost from $1.50 to $4.50 per square foot. Geofoam costs $2 to $4 per square foot, and then those geosynthetic clay liners cost from $1.50 to $5 per square foot. So answer here is B, geosynthetic clay liners. Question two, what is the only piece of equipment you'll need for installing geotextiles alone? Now, if y'all remember from slide, I think it was two or three. No, it was three. It was three. I went over the equipment needed to install uh, geotextiles and a highway, and more particularly geotextiles. But there was only one piece of equipment you needed for geotextiles, and it's not a roller. It's not a compactor. Compactor, you need that for after the asphalt is laid down. So the answer is B, heavy duty sewing machine. You cannot come onto the job site with your grandma's sewing machine. Remember that. Question three, what is the purpose of geosynthetics? Is it to stabilize and reinforce soil, to act as a waterproof barrier, to assist in drainage, or all of the above? Now, if you've been listening, you'll know immediately that it is D, all of the above. And that is it for today. Like I said, that is it for today. Thank y'all for watching, and I hope y'all have a great rest of your day.